Okay, this video is going to show you how to do different regressions instead of just a linear regression, how to do nonlinear ones. So if I make a scatter plot of this data, I'm pretty positive it's going to be an obvious trend, a curved trend instead of a straight line trend. So we know how to do linear regression. We go to customize, we go to series, we go to trend line, and you get a line of best fit, but it's fairly obvious that it's not going to be a good line of best fit. And so what I can do is I can change it from linear to exponential or polynomial, and I can even change the degree of the polynomial, so what kind of exponent I want. But how do we know which curve is best? Obviously the curve that follows the trend the best and passes through as many points as possible. But there is a calculation. If we click on show r squared, that is going to tell us which curve is the best. So exponential is 0.947, pretty good. But if I go to polynomial degree 2, I get a 0.987, even higher, closer to 1. And if I go to polynomial degree 3, I get 0.99, an even better curve of best fit. Now one thing you do have to consider is what that trend line looks afterwards and before. So there is a big difference between a quadratic graph, that's a parabola, that goes down and goes back up, and then a cubic graph, like x cubed, and that is one that goes up, kind of levels out, and then goes up again, versus an exponential graph, which is one that starts off slowly and rises faster and faster and faster. But you're looking for the highest r squared value to know which one's best, other than if you go to polynomial and if you make this degree up to 10, you're going to get the highest r squared value, but you're going to get a bit of a bizarre curve that doesn't necessarily fit the trend line. So you do want, it's not connect the dots, you do want more of a general curve that represents the trend.